Okay, so we were discussing about the rules of figuring out the oxidation numbers. Okay, so now oxidation number of alkali metals is +1. This is very easy to understand because they lie in the group 1, so that means they will release 1 electron. Okay, oxidation number of alkaline earth metal is +2. This is also easy to understand. Okay, and let me remind you of the alkali metals again in case you have forgotten. Okay, so this is okay, and alkaline earth metals are okay. Okay, so these are the alkaline earth metals. Alkaline earth, and these are alkali metals. Okay. Oxidation number of halogen in metal halide is -1. Okay. The halogens are fluorine, chlorine, bromine, iodine, astatine. Okay. Fluorine, chlorine, bromine, iodine, astatine. If they form any like metal halide, like say for instance sodium chloride could be a metal halide, magnesium chloride could be a metal halide. In these cases, the I mean, what can I say? Oxidation number of these halogens will be -1. Okay. Say in case of magnesium chloride, the oxidation number of chlorine is -1. Lithium chloride, oxidation number of chlorine is -1. Same could be like sodium bromide. In case of sodium bromide, the oxidation number will be -1 as well. Okay. In most compounds, oxidation number of hydrogen is +1, but oxidation number of hydrogen in metal hydride is -1. Okay. In case of metal hydride, the oxidation number will be -1. Okay, I think I have mistaken something previously. So as I said previously that NH4 plus. Okay, in this case I considered nitrogen's oxidation number to a minus. No, that is in fact incorrect. This will be okay. Why doesn't it? So sodium's oxidation, nitrogen's oxidation number here will be +5. Okay, and hydrogens will be equal to -1. Just correct it. Okay, and you can do it alone as well. So just cut the line of previously or just correct it in the previous. Okay, so nitrogen's oxidation number there will be +5 and hydrogens will be -1. All right.
Then wouldn't it be a minus?
No, it won't be minus. Nitrogen is +5 and -1 multiplied by 4. Hydrogens are 4, right? So -1 multiplied by 4 will be
-. Okay, yeah. The first one. Yeah.
Okay, now, all right. So now in case of ammonia, or as they're saying metal hydride, which is you could say nitrogen hydride, maybe, I don't know, I haven't heard this term. So in case of metal hydrides like NH3 or maybe lithium tetrahydroaluminate, okay, so very difficult names, you don't need these names as of now. You might need them later. So see, in case of nitrogen, nitrogen shows somewhat like metal properties, and lithium and aluminum show like very strong metal properties actually, especially lithium. So if hydrogen gets like attracted with these, okay, in that case, hydrogen's oxidation number will be -1. Okay, -1. Now tell me one thing. Do you have any idea why, if hydrogen gets attached to with a metal, hydrogen's oxidation number seems to be -1? Or if I like simplify it a little more. Oh, okay, all right. Yeah, yes. No. Okay. Let me rephrase the things. Okay, just a second. So in case of metal hydrides, the oxidation number of hydrogen will be -1. But if they are not involved in any metal hydrides, that will be +1. Okay. So sorry for my mistake again, that I was correct previously in case of NH4 plus. Okay. So see, in case of NH3, that is, in case of NH3, you will consider nitrogen to be -3. Okay. And hydrogen to be +1. Why? Because it's not a metal hydride, not a metal hydride. Not a metal hydride. Okay. And again, in case of NH4 plus, you will consider hydrogen to be +1 and nitrogen to be -3. Why? Because it's not a metal hydride. It's not a metal hydride. But in case of, say, lithium tetrahydroaluminate or LiLH4, +1 for hydrogen, +3 for -1 for hydrogen, +3 for aluminum, and +1 for lithium. Why? Because it's a metal hydride. Okay, so all of that being said, now tell me a thing, that why do you think I have written all the oxidation numbers as well in case of ammonia, ammonium ion, and metal hydride? Okay, let me give you a more easier metal hydride, that is sodium hydride. Okay, so in case of sodium hydride, sodium is +1 and hydrogen is -1. Now, why do you think in case of metal hydrides, hydrogens have oxidation number of -1, and in case of normal cases, hydrogen has an oxidation number of +1? Why is it so? Why does it change in case of metal hydrides? Let's see, how is your intuition power? You are given with
So
the
why does hydrogen become a negative when it's with metals?
yes.
Because it's the equivalent of taking an electron for hydrogen and giving electron. It has the same sort of power, I guess. So if it was a cation, which metals normally are,
Mhm.
it would be safe to take the electron from the metal.
Okay.
No? Terrible? Yeah,
Alright,
okay. Makes
I mean,
sense.
yes, so I understand where you are going, but see, okay, the answer could have been like this. See, any sort of metal hydride, okay, if they don't have any charge, that means they are charge neutral, right? They have to be
Yes.
charge neutral, that is 0. Now, is it possible for any sort of metal to like release electron? Sorry, I mean accept electron, that is?
No.
It's possible, I guess, if you like provide say 1 million kilojoule of energy, they might
Oh.
agree to accept an electron, but in general cases it does not happen. Okay, so that means metals will obviously donate electrons. Now we are willing to make a compound involving a metal and hydrogen. So the thing here is to someone has to receive the electron, and metal won't be the recipient. So that is why hydrogen has some property where it receives electrons. That is why hydrogen takes that property here in case of like metal hydrides and receives electron from the donated electron of the metals. Okay, so yes, or the part you said that it's safe for hydrogen to take electrons, that is okay, but you have to like mention the charge neutrality, and also that metals cannot receive electron. Okay, all right, so then it will get good marks at this. Okay, all right, next up. I hope you have understood these things, right? The metal hydride.
Yes.
Okay, good. Now, next up, in most compounds, oxidation number of, okay, so we read that, and in most compounds, so oxides, oxidation number of oxygen is -2. Listen very carefully. In most oxides, you will see that the oxidation number of oxygen is -2. But in case of peroxides, oxidation number is -1, and in case of superoxides, it's -1. So how will you identify it? the identification is fairly easier. That is the element involved with oxygen. In like 99% of the scenarios, you will know the oxidation number of them. Okay. Say for instance, K2O. Okay. Now we obviously know that potassium is a alkali metal. So that means what will be the oxidation number of alkali metal? Tell me.
1.
1 plus 1, right? It will be plus 1. And for oxygen, it will be minus 2. Okay. All right. Why? Because plus 1 multiplied by 2 equals to plus 2. Okay. Understand my point? Yeah, and it has to be charge neutral. And in case of K2O2, again, potassium is plus 1. Okay. So plus 1 multiplied by 2 equals to plus 2. Okay. Now oxygen is minus 2. But how many oxygens are there? How many
1.
oxygens? 2. K2O2.
2.
Yes.
K2O2. Okay, makes sense.
Yes. K2O2. All right. So it's like potassium peroxide. I mean, for simplification or understanding, that is why I'm saying that. So oxygen, I mean, 2 oxygens account for minus 2 charge. Okay, so 1 oxygen accounts for minus 2 upon 2 equals to minus 1 charge, right? Oxidation number.
Yes.
So that is how we understand that in case of peroxides, the oxygen's oxidation number will be minus 1. And in case of superoxides, like say sodium superoxide, this is plus 1, okay, and this is minus 2. Okay, and now notice you have to sorry, this is not minus 2, this is minus 1 rather. 1 second. All right, this has to be minus 1. Now minus 1 accounts for 2 oxygens, right? So minus 1 upon 2 accounts for 1 oxygen, which is minus 0.5. I'm involving fractions. I hope you understand. Sometimes students get confused with this. Understanding, right?
Yes, I understand.
Okay, all right. So in case of like if you can't figure out which element is like superoxide or peroxide or normal oxides, you could perform this operation where you involve like the what can I say? Involve operations regarding calculating the oxidation numbers of oxygen. Okay. Then if you get minus 2, it will be a normal oxide. If you get minus 1, it will be a peroxide. In case of minus 1, you will get a superoxide. Okay. Okay, now last thing for today, you might as well sometimes get questions like this. Say, for instance, you will be given with a compound of which you know, say there are 3 elements in a compound of which you know the oxidation number of 2 elements, and we will be asked to calculate the oxidation number of the 3rd element. Say for instance, you are given with potassium permanganate. Okay, so you will have to calculate the oxidation number of manganese here. So how will you calculate it? Okay, so now tell me what will be the oxidation number of potassium here? Plus 1, right?
Yes.
And for oxygen it is minus 2. Okay, so now you will consider the oxidation number of manganese to be X. Okay, now we know that plus 1 multiplied by 1 plus X multiplied by 1 minus, or you could say like plus minus multiplied by 4 equals to 0 because it's charge neutral, right?
Yes.
So now let's calculate 1 plus X minus 8 equals to 0. That gives us X minus 7 equals to 0, X equals to 7. Okay, so the charge for manganese here will be plus 7, or the oxidation number will be plus 7. Okay. All right. So you could get questions like this for 2 marks or maybe like MCQs. Okay, we used to get MCQs regarding this, but if we are very lucky, like the question set is very kind to us, they would have given to us like 3 marks as well. okay, for this question, which was a rare scenario actually. All right. Okay, so now, okay, just complete this one, and you should. I will give you. I mean, what can I say? Break for today. Okay, so H2SO4.
Okay.
Calculate the oxidation number of sulfur here. Okay, H2SO4. H2SO4.
Six plus six.
Yes, +6. You're correct. Okay. All right, so that's good. And there are some exercises here. We could discuss them, or maybe give you homework. What should I do? Actually, let me give you this homework. Okay, take a screenshot of this. These will take like 20 to 30 seconds, each of them. Okay. All right. And
Yes.
take a screenshot of this as well. And you should be memorizing this. Okay. It's not even difficult to memorize. Right. This is very easy to memorize. Just read it out 2 or 3 times. Okay.
Okay.
And try to send me the digital copies of the books as soon as possible by consulting others. And when can we meet next? Tomorrow when are you free?
Well, I come home at, hold on 1 second. I finish at 1 and I'll come home at like 2, so 2:30
2:30 your time.
slash 10:30, yeah.
All right.
Or yeah.
10:30. Okay, 10:30. Can we make it 11?
Yeah, I can do 11. So
Or
it's 3/11.
okay. Or if you want, like I mean, otherwise it will be a tight schedule for you, I guess. That you might have to delay it for 15 minutes or something. So that is why I said 11 should be good, right?
For
Yes. Is it okay?
Oh yeah, true. Yeah, it makes sense. Yeah.
11
Boss is so
a.m.
weird
or
here.
11 a.m. 3 p.m. Time is 5th October. 5th October
Yes.
Wednesday, and I'm giving you the time in WhatsApp as well. Okay.
Yeah.
All right, Allah Hafiz for today, and thank you for arranging the time, because I have to go to a dawat actually. So yeah.
Yeah. Have fun at Dawat. The look
It's
and
not a
anyways.
fun thing actually. I mean, there's a ritual. I mean, when someone dies, it's. Have you heard about the term Milad Mahfil?
No.
Okay, so it's in our, I mean, Bengali culture actually. So they, the people gather together, like, and say they perform a dua for the departed soul, and then you get into some sort of, like, what can I say? You take some. In case of some Milad Mahfils, you take some snacks. In case of some Milad Mahfils, they might arrange some meal for you. Okay, like that it works. It's not a like very pleasant occasion, and very close to me. I mean, my sister-in-law's father has died. It was at the 2nd of October, actually at the 12 a.m., like when the 2nd of October started. So pray for his departed soul as well. Okay.
I will.
He was a very kind person.
Yeah.
I hope he
I'll
gets
read
Jannatul Firdaus.
Mm.
All right. So me too. Tomorrow. Okay.
Inshallah.
Hafiz.
I love this for today.